So welcome to this talk. So Trojan Source code, I will explain a little bit of what it is, but before I start, I just want to put some disclaimer at the beginning that it's going to be mainly in the Python's perspective. So it actually is not limited to just Python code. So that's why I put it there, because I will be mainly focused on Python. I guess that's what you're interested in. So that's why we will focus on Python. So also, this is my contact detail. You can hit me on Twitter if you like. Yeah. So first of all, before I start, I would, it's a little bit difficult to see, isn't it? But if you can see it, maybe you can try to tell me whether there's something wrong in this code. Yeah, I know it's a bit, wow, it's a bit difficult to see. So yeah, so you can see the hello equals to hello world, and then so what do you think it will happen, right? Yeah, so it's just hello equal to hello world, and then world equal to hello, and then print world. So so yeah, I think it's not too kind of so. Okay, I would actually try to run this code, and sorry, I forgot to do this because I don't know, I forgot that I can't copy and paste the code if I don't do this. Okay, oops, one step ahead. Okay, fine. So let's do this in a interpreter. So yeah, it's very difficult to see. So I would just run it in the interpreter to see if you can. Yeah, I can copy and paste it. Luckily, okay. Can I zoom in a little bit? I don't know how to zoom in with the computer. But anyway, yeah. So I just copy the code and let's run it and see what's happened. So why you do this to me? Okay, fine. I will just run it, and come on, let's run it. Okay, so it's hello world, right? There's nothing wrong. It's just print out hello world, right? So it's a trick question, so there's nothing wrong with the code. But as I accidentally press it, you can see that I have another code snippet here that is exactly the same thing. I know it's difficult to see, so I won't ask you to squint your eyes and try to look at it again. So. So let's see, so it's exactly the same, right? Just look exactly the same, trust me, or I can give you the link to the slides later and you can, see that it's exactly the same. So I'll just run it, and this time there's an error, right? So for those of you who sit at the front, you can see that we have a syntax error here, and why is it the case? This is so simple, right? It's just like printing hello world, but why do we have a syntax error? So, so maybe you already know what I'm going to say in the next 20 minutes or so. But before I tell you what's going on, myself, I'm Cheuk, and I love open source projects. I work on a few projects in the past. I'm now working in TerminusDB, which is an open source graph database. You can talk to me about that later. And then I also like organizing events for the community. So I will tell you about one of the events that's coming next month very soon. And then also I stream a little bit on Twitch, but I stopped doing that nowadays because I'm traveling too much. So we have all seen this, right? This is a meme that is floating online, you may have experienced that yourself. I'm glad that this year, in the batch, you can actually print out an emoji. But in the past, if you put an emoji in, try to put it in your tagline or something, it won't print out sometimes, But this year it will print out, so that's great. But that's something that we have experienced in the past, that we can't print out the Unicode. So Unicode is very weird. Also, well, it provides very, very good lightning talk materials because Python, actually, fun fact, you can use Unicode in Python. So this is my friend Mark Glacia, and he is giving a lightning talk in PyData. I forgot which PyData was it, but he was talking about importing pandas as panda emoji, which is fun. You can do that. You can try doing it. So, pandas as PD is boring. So why not use emoji? So there's actually a lot of lightning talk about messing with Unicode in your Python code, and it's fun, right? So one year I come up with an idea that, how about if we answer a question on Stack Overflow, we can put a no width Unicode character in there, so someone copy and paste the code and it won't work. So that's similar to the trick that I've done earlier, that you can see that the code looks exactly legit, look exactly normal, but there may be something hidden in your code. So yeah, so Unicode is not just like for fun. Of course, lightning talk is fun. I mean, like we all know it, but is also actually very useful because when someone invented Unicode, of course they don't have lightning talk in mind that like oh you can import pandas as panda emoji, right? So people was trying to solve a problem because there are different writing systems in the world. Not all of them look like English, or most European languages is alphabet, sometimes with accents, and then reading from left to right. Sometimes it's different. Sometimes writing systems are from right to left. For example, some Arabic or Hebrew characters they're different. So Unicode is not a new invention, actually. It was kind of back to like a long time ago in the 90s. I remember I was a kid in the 90s, and I was starting to learn how to use computer at school, because at that time computer is new thing, and all the kids was put to a computer lab and learn how to use computer. So at the time I was used like Netscape. I was like browsing all the exciting internet that like you can find anything online, which is very fun. I remember there was a thing that at that time, Unicode is not the standard yet. It's not that popular for writing. When someone create a website, they don't have that in mind that they have to care about different writing system in the world. So most of it like it's just ASCII is enough, and then even Netscape maybe like the default is just like using ASCII character. So when I see a Chinese website, let's say because I grew up in Hong Kong, so the language is Cantonese Chinese, then I would see weird weird symbols on the website because the browser thing that is ASCII doesn't switch to Unicode. But if you switch to Unicode, I think most popular is UTF-8. There's others as well, but nowadays I think UTF-8 is the standard. Then if you switch to that coding, then you will see most of the other characters just fine. And also nowadays, browser can detect the language or the person who created the website already encode, like say that what encoding should be. So now it's very, very good. Also, we love emoji, right? Like the pandas emoji was an example. This is how a thumbs up look like in a window machine. I found it weird because I use I have an iPhone, I use Mac, so I'm not used to this this thumbs up picture. But yeah, like emoji, we all love it. We use it a lot when we message friends, and people. So it's yeah, all of these like things that we are familiar with. Most of them are added in 2014. So there are actually some older emojis. For example, you may I remember like when I create some the Microsoft documents, those things, you can change the fonts into wingdings. Those are actually symbols, right? Like those are actually like older version of emoji. In Japan, there's also like when people are sending messages to each other, they would use different characters to make some faces. So that's actually how emoji was invented. But those are just like some fun fact about Unicode. What we should care about today is this one, is a bidirectional text. So what are they? So like I said before, that some languages is not written from left to right. Some of them are right to left, like Arabic and Hebrew. Just two examples, there are more. I always use Chinese as an example. It's my mother tongue. So like in the old Asian Chinese, like we always write from top to down, like top down, like up down, and then from right to left. It's so weird. So like how can we recreate that in computer? So that's why when people try to solve the problem of handling different writing system with Unicode, they have to solve this problem: how to tell the computer. This text actually is supposed to be from right to left, not from left to right, what we assume it is in most European languages. So we have to have a hidden character that is not visible for human eyes. Well, it's just not displayed on the screen. But when a computer scans to that character, then oh, I should display it in the other direction, from right to left. So I should go to the end of whatever text space that you have. So it should be the end. The cursor will jump to the end and then go from that direction to the left. So that's how the bidirectional character works. So now let's gather our thoughts. Actually, we have a problem because we just assume everything is from left to right, especially in code, because code is based on English, right? English is left to right, so we just assume everything is from left to right. But if you use it in code, and if someone put that character in it, what we see and what the computer see will actually differ, because we can't see that functional character, the character that tell the computer to flip the order of scanning things, and we just assume everything from left to right, then things would happen. So this is why the Trojan Source malware will create some problems when we read some code that actually was strategically make to trick our eyes to think that it's a normal code, but actually it doesn't for the computer. So this is, I always struggle to explain the Trojan horse, the story. I think I have heard this story when I was a kid, but I'm not very good at history, so I always forget. I think this is something happened in a Greek city. Correct me afterwards if I was wrong. And this is a city that was so some people want to reconquer the city. I believe. So what happened is that so these people in the city assume that they have a victory, so they just celebrating, drinking, like what we did last night in the social event. So. But the enemy, right? They want to reconquer the city. So what happened is that they give them this horse as a gift, but inside this gigantic horse, they have some soldier hidden inside. So by the time everybody got drunk, the soldier can come out and take the victory. So I think this is kind of a legendary story. I don't know whether that's correct or not, whether it really happens, but that's why we always say, Trojan horse is something that, is hidden from your eyes and is kind of intrude your computer or intrude your code by deceiving you. So. This is what people found. Not me. I didn't do anything for this research. There was a bunch of computer science researchers. They found out that actually, by exploiting this Unicode behaviors, you can actually inject some, unwelcomed code inside the source code. So in the paper, so the link of the paper is here. You can read it if you're really interested in this topic. So there's actually 3 types of attack that can be done. One is early return. So it's kind of terminate a function early. So it would, can perform some dangerous things. Also, you can comment out some of the code that you think it will execute, but actually it won't. And also the string, also it will include things in a string that you are not expecting to be there. So let's look at some example. This one is in Python. So you can see that the first line, it says Python 3, so it's obviously Python. So sorry if it's very difficult to see again. This is not very. The projector is not contrasting it, and this is the biggest I can put on the screen. So sorry about that. So this is just a Python code that is assuming that we are working for bank, right? This is just a demonstration. So obviously a bank won't just write this code. Or maybe they do, I don't know. So you can see that, there's a doc string there. It's documented. It looks fine, except, if you really look at it, then it's a bit funny that why they have a return colon in the doc string. A lot of times, we won't put a semicolon at the end of a sentence. So why? So actually, there's an attack that's going on here. So there's actually hidden bidirectional character there, so it will flip the order. So what happened here is that it will flip the order of the quotations and the return. So what happened here is that the doc string will end there, and then it would just have the semicolon. So in Python, actually, it will function as an enter. So the next line will be returned. So the line below, which is like deducting the amount, won't execute at all. So this will work in the interpreter and just fine. You won't see a syntax error or anything, but it is behaving not as what you're expecting. So it won't subtract the funds. So that's what it's going to do. So that was the first example, early return. This is commenting out. So unfortunately, this example is not written in Python. That's what I found on the paper. Like I said, this attack is not limited to Python. So that's why they used other programming language as an example. But this one is not too unfamiliar. So for those of you who already know C, then it's you know what it is. So there are some comments there. So the slash star actually, or star slash, so between those actually are the comments for C code. So yeah, you can see that, this is just a normal code with some comment, but if you inspect it with showing all the hidden characters, you will see that it flip all the orders is a bit crazy here. This is a more, a sophisticated attack. So it flip all the orders to make some of the code that looks like the code will become a comment. So it won't execute. It won't do the if checking here. So yeah, so it could be dangerous. Of course, this is silly code, but this is the shortest example that they think of. Another thing, so it's very similar, is that this look like, user, right? User is a string. But again, this is in, I believe this is a JavaScript. So the slash is the comment. So it's just some code with some comment there. But if you inspect it properly, then you see that, look at the second user there, like the quotation actually include all these things that's supposed to be in the comment. So it's not a string that is just user, it's rubbish. So it won't work. Well, it will execute, but it won't work as what you expected. So, yeah, so that's actually not that good if you think about that, because we all do open source, contribution and stuff. So everybody can contribute to open source. We can see the code, but what if what we see is not what it actually is? Then it's quite dangerous. There are other similar exploitations. These are not categorized in those like Trojan Source code attack, but it's using similar ideas. For example, invisible character, like I explained before, I already come up with this idea in the pub, so anybody can do that. It's just an invisible character that you can't see it, and just insert it somewhere in the code, and it will mess up the code. Also, homographs is a more I won't say sophisticated, but it's just like swap. Because homographs just means that two characters look the same. So you can just swap out some characters in, let's say, the function name here. Then, because this is C, so it would just like default, it will execute the first one. In Python, it's the other way around if you want to create this attack. So, this would just, if they are actually the same, you assume that they run the first the definition of the function, but actually, because the blue H and the red H, they are different, so it will execute the second one. So yeah, it's not good. So what works in Python? So we all care about this. I will just give you a brief summary. So this is what it works. So I already showed that early return works. Commenting out actually, according to the paper, it works on these versions of Python and this OS. But if you really want to, you can test it out on the new version of Python, 3.10, 3.11. But in invisible function, it does not work on Python, which is good. So yeah, you can have a look at the GitHub and see the code, and also try it out yourself maybe. So maybe you will find some interesting things. So what should we do? Should we worry about it a lot and stay away from code? No. Or shall we just ban the use of bidirectional control characters? I would say that that's a very extreme measure. I don't have a good answer here. I'm not I'm not in a steering council. I'm not a core developer. I'm just like a Pythonister that have some opinion. So I don't think we have to be that worried, but we do have to be careful. So Use a text editor with good syntax highlighting. So for the example I show at the beginning, the Hello World one, that one actually takes me quite a while to find that online interpreter that doesn't highlight these kind of things. Most interpreter and text editor actually will do the highlighting for you. So for example, it scans something that is invisible, Unicode character. It will show some symbols or something to show you, oh, there's something that you didn't see here, but I have sensed it, so I show you. So that's really good. For example, syntax highlighting, it will also highlight those the monographs that are actually like, they look the same, but it will just do some coloring for you so you can see that they're different. Also, you can, there's also other tools that can scan all the Unicode characters that is invisible in a text. So you can also do that. For example, GitHub, so those examples that I showed in the previous slides, if you go to their GitHub and see this attack that is demonstrated, people won't be fooled because GitHub will have a yellow flag that tell you, oh, there's actually some bidirectional character in this source code, so be careful. Yeah, so GitHub already done it for you. It scans whether there's something that is dangerous and then will tell you. So it's relatively safe. A good linter will also help. I've been told that Pylin actually would tell you there's someone's nodding their head. Yes, it would show you like what, there's any weird things in the code. So which is good. I always, especially because I was this person before, when I was a beginner, I look for a lot of questions that I don't know how to do this thing that I want to do, so I would just see whether someone have already write a code snippet on Stack Overflow that already done the job, right? And I would just copy it. But before you run the code, especially copy from a source that is anywhere on the internet, make sure you check it, do all these steps before you run the code, because it could be a malware. So we all love Unicodes and emojis. We still want to have fun with it, but just be a little bit careful about what you're running. So yeah, this is the website, trojansource.codes. That's actually where the researcher published the findings, so you can go there and have a deeper dive. So at the end of the talk, I will remind you again, there's EuroPython next month. It's going to be nice, it's going to be Dublin. We're going to have a lot of fun. So thank you for listening to me. Thank you.
So now is question answering time. And at the moment, the Slido app is empty. So I will call for any real-life question. Anybody? Very good.
What about git diff in the terminal, for example? Are you able to see strange charts?
That's actually a very good question. So it actually depends on, so if you, let's say you run it on the terminal, right? So if let's say, I just, like not even in git diff, I just try to, let's say you open you can open a Python, interactive command thing, right? And I forgot the name of that. But I've tried to copy those that code that I demonstrate and paste it there and run it. But the thing is, like, my terminal is so good that it will show me that I've put in a hidden character there. So it depends on the terminal that you're running. But I think most of them will have this warning. Yeah.
Thanks for such a great, interesting talk. I was wondering about the comments approach that you talked about. So how can you detect this? Because I think you mentioned that it's like will not complain about this when it's in the doc strings. And yeah, I have to say personally, I scan doc strings, but I would maybe miss this. So what ways can we protect ourselves against that?
So there are different defenses you can do. So the first thing is that, for example, that code, if you copy and paste it in let's say a modern IDE, like PyCharm or the common ones, the VS Code, all those things, I think they will highlight it for you and show you that there's some hidden character there. So that's the first line of defense. The second line of defense, again, linting is very good. It's a good practice to lint code. So yeah, that would also tell you that there's some something hidden there you can't see, and it will just warn you that it's either a very bad code or there's something hidden there. So yeah.
Is there any other question? So maybe I can come up with one. So similar things happen in domains names, which is called cyber squatting. And well, we are in a Python conference, so the question is there something happening also on the, for instance, in the pip install requirements? I mean, yeah.
Yeah, that's a very good question, because pip install, we all have this problem. So I can't have a good answer for especially like what you said. For example, someone used the characters that look the same, but for example, pandas, I swapped the A with another A that look exactly the same. We will install a malfunction of pandas. I don't know. I don't have a good answer. But a lot of times when I was a beginner, a lot of times, I was so worried that, like, for example, pandas, I missed the S, then I would install something called panda that I don't know what it is. So what I would do is that for the libraries that I use, I would Google it first. So because if it's a very popular library, you probably will see it popping up on Google, and you can click on the website to see like whether that's a legit documentation website and all these things. So if it looks legit, then you can like look at the installation guideline. It would always tell you how to pip install it. Then you can make sure that you're installing the correct thing. So that's how I defend it when I was a beginner, and be a little bit more careful. Yeah.
So I would say thank you very much, and see you at EuroPython. Yeah.